This will be the final video for section 1, the math or chemistry section, and this video is on graphing. As I've said ad nauseum, chemistry is a mathematical science, and one of the things we do in chemistry is we like to collect data. Once we collect data, we need to ask the question, are the data related? As an aside, data is plural, so yes, it is data are. Datum is the singular, and datum is. So yes, are the data related? It turns out that when you have a collection of numerical data, best thing to do is graph. Let me repeat that. When you get a collection of numbers, graph it. Graph is a picture. And as we all know, a picture is worth 1,000 words. Graphs reveal patterns between numbers that may not look like they are related. So for example, it's a snowy day. Elphaba decides that she's going to skip taking the bus and she's going to drive to school. On the way to school, she looks down and she notices her tire warning light is on. She's got to check the pressure in the left front tire. She happens to look at the thermometer and sees that it's 0 degrees Fahrenheit outside. She doesn't think much of it. She goes to school. She does her usual stuff. It's a good day because she had chemistry. At the end of the day, she goes out. She starts up the car. The warning light is off. She looks at the temperature and she sees that it's 68 degrees Fahrenheit. And a thought comes to her. Would air temperature affect the tire pressure? And then she goes, that sounds really, really familiar, but she can't remember where she heard it before. Anyway, she decides to do an experiment. In her experiment, she's going to place the tire at varying temperature levels, and then she will measure the resulting PSI. The temperature, which is being determined by Elphaba, while the PSI is being measured in response to the temperature. We can thus say the temperature is the independent variable or the manipulated variable. It's the variable that Elphaba is changing. It goes on the x-axis of a graph. PSI is the dependent variable or the responding variable. It's responding to what Elphaba does. It goes on the y-axis. And to help you remember this, I learned over the summer of a mnemonic called dry mix. The dependent or responding variable goes on the y-axis, while the manipulated variable or independent variable goes on the x-axis. Dry mix. Elphaba does her experiment. You can see the results here. She started at minus 10 degrees Fahrenheit, went up as high as 85 degrees Fahrenheit, and then she saw what the resulting tire pressure was. And she knows to graph it. Now, there are multiple types of graphs. There are bar graphs, there are pie charts, and the only purpose for these two, as far as I can see, is it gives little kids something to color in. There's a connect the dots graph, where you connect all the points, but that's really just good if you're traveling long distances in the car and you're bored. We use scatter plots. A scatter plot is similar to the last graph we saw, but slightly different. How do you do this? Well, making a graph, once again, follow the steps. Start with your graph. Now here, you see that on the x-axis, we go from 0 to 100 for a value, and on the y-axis, we go from 0 to 40. When we take a look at our data, we see that the temperature that should go on the x-axis goes from minus 10 to 85, and the PSI goes from 26.3 to 32. Now when you do a graph, you don't have to start with axes that begin at 0 for both the x and the y-axis. You can adjust them. So here on the x-axis, which is where the temperature is going to go, we made the range go from minus 20 to 90 degrees Fahrenheit. You want to go above and below the value of your data. And on the y-axis, we went from 25 to 35 psi because all the tire pressures were greater than 26 but less than 35. So this will give us an appropriate scale so we can see patterns. After you have the appropriate scale, you need a title. All graphs need a title. And the title should be related to the experiment. So here, the effect of air temperature on tire pressure. Appropriately label the x-axis, including units. Label the y-axis, don't forget units. Now you just take your data, plot it in the normal XY fashion, and you get something that looks like this. This is a scatter plot. Notice the dots are not connected. However, the overall pattern that seems to be emerging is that of a straight line. And when that occurs, we add what is called best fit straight line. It's a straight line that, if you're doing this by hand, you do to the best of your ability. That makes it so that the average distance between all of the points comes out to be about 0. So fewer above, fewer below, some are almost right on. If you use a computer program, and I will show you how to use a computer program, then it will actually calculate the best line for you. So now you have an appropriate scatter plot. Now, because it's a straight line, the straight line equation y equals mx plus b comes into play and is going to play a major role. So looking at that, if we go to where the temperature is 0, we can see that the y value when x is 0 is 27.3 psi, and so we now know that B equals 27.3 degrees Fahrenheit. So now our straight line equation looks like this. M is the change in y over the change in x, the rise over the run. We already know the values for a temperature of 0 degrees Fahrenheit. That's 0, 27.3. Now we're going to look at 50 degrees Fahrenheit, and that looks to be 20, and that appears to be 30.4 psi for the corresponding y value. So we set the slope equation up, we calculate the slope. We now have the equation for the best fit straight line. Why did we want to do this? Because graphs allow you to make predictions. This is the beauty of a graph. There are two ways to do this. For example, what should the tire pressure be if the temperature is 28 degrees Fahrenheit? The first way to do this is called graphical, using the graph. You pull up the graph. You know that you're interested in 28 degrees Fahrenheit, so you find 28 degrees Fahrenheit on the scale. Draw a line straight up till it intersects the best fit straight line. Make a turn 90 degrees. Extend the line over to the y-axis, and now read off the value, and I read that it's 29.0 psi. If I gave you the y value and asked for the temperature, you would just do this in reverse. Now when you're doing things graphically, you can figure things out either what is called by interpolating or extrapolating. When you interpolate, you are looking to predict the result within the values of the data obtained. We measured experimentally from -10 to 85, so 28 degrees is within that, so that was an interpolation. Extrapolation is predicting outside the values of the data obtained. For example, suppose we wanted to know what the pressure would be at a temperature of -13 degrees Fahrenheit. The lowest temperature we measured was -10, so we are going outside that range. So we start with the graph that we had, and now we extend the straight line to the left and pretend that it's all one continuous line. Now you do the same thing. Find -13. Draw the line up, draw the line over, and you get 26.5 psi. Mathematically, we're going to use the y equals mx plus b formula. So we're going to go with 28.0 degrees Fahrenheit. Plug that into the equation. When you solve it, you get y equals 29.036 psi, which, for reasons that will be explained in section 2, is rounded to 29.0 psi. So when the temperature is 28 degrees Fahrenheit, if you look graphically, you get a result of 29 psi. When you do it mathematically, it's 29.0 psi. I don't see how you get much closer than that. Frequently, there's a very slight difference between the two, but that's within experimental error. By the way, if you happen to do this from -13 degrees Fahrenheit, you will come up with 26.5 psi mathematically, which is the same as you got graphically. So to review, when you get a collection of numbers, think graph. 1A, when you get a collection of numbers, think graph. This is really useful for standardized testing. The graph that we are going to use 99% of the time in this classroom is the scatter plot. Don't make bar charts. Don't make pie charts just because you want to color them in. Don't play connect the dots. There are 4 parts to any graph: appropriately scaled axes, a title pertinent to the experiment, the independent or manipulated data on the x-axis, and the axis labeled with correct units, the dependent or responding data on the y-axis with the axis labeled with correct units. If the data looks like a straight line add the line of best fit. Do not play connect the dots. Remember, there are two ways to make predictions: graphically and mathematically. The former, surprisingly enough, uses the graph. The latter uses the, in our case, y equals mx plus b. You can interpolate, where you make a prediction within the values of the data obtained, and you can extrapolate, going to go outside the values of the data obtained. So congratulations, you have finished section 1. Finish up the worksheets, do the activity for graphing, make sure you've done the quizzes and the exam, and then we'll move on to section 2, which is on scientific measurement.